Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Hope so, doing really great. So students, in last video we have covered the orbital velocity and time period of the satellite. In this video we are going to cover rest of the terms like what is the energy, how much work is needed to change the orbit of the satellite. Is it all these basic things we will see. At the end we will see geostationary and polar satellite also. In an exam, geostationary satellite is very important, so watch it very properly. Okay students, so let's start the video. So here you can see important terms related to the satellite motion. Okay, so see here, please here. As I told you, the third term is what? Mechanical energy of satellite. And you know very well, mechanical energy means potential energy and kinetic energy. Both we have to combine, then only we'll get the mechanical energy. Okay, so we will see one by one here. So here, students, I have taken here one planet is there. Let's take its mass is m and the radius is r. Okay, now what is happening around the planet? Now one satellite is there, very point mass satellite, is it? And it is revolving in a orbit. Okay, and the radius of the orbit, how much here? Small r. And if we talk about here orbital velocity of the satellite, this is v0 is there. Okay, after that students, for example, if in case the height of the satellite is h from the surface of the planet, then by the diagram even we can tell small r equal to r plus h. And if the satellite is very close to the planet, we will tell small r is approximately equal to capital R, h will be 0. Okay, so now in this situation students, if I talk about here the potential energy, so potential energy formula you know very well. Actually the potential energy is defined for the pair of masses. Here how many masses are there? One is the mass of the planet and another one is the mass of the satellite small m. Okay, so for the pair of masses, potential energy of this system is given by minus g capital M small m by r. You know very well, capital M mass of the planet, small m mass of the satellite, and small r is the orbital radius. And the gravitational potential energy will be always negative. At infinite distance outside of the gravitational field of the planet only it will be 0. Okay, now after that if I talk about here the kinetic energy, so kinetic energy is given by k equal to, we know the formula very well. Is it? What is the formula? Half m v0 square. So here half m v0 value how much? We have seen in the last video, root g m by r whole square. So when you will simplify this kinetic energy will come. Just see please, it will become here g capital M small m by 2r. Now our potential energy is ready and our kinetic energy is also ready. After knowing both of them, we are going to move for the next one. And what is this students? Next one is the mechanical energy. And what is the mechanical energy? See please, E equal to U plus K. Okay, so what is U? U we know very well, minus G capital M small m by r plus G capital M small m by 2r. Okay, after that what will happen that here? We'll simplify this here. So if we'll see here, G capital M small m by r common, that means minus 1 plus 1 by 2. And this one will come how much? Minus 1 by 2. That means we can tell here the mechanical energy of the satellite. This is going to be minus G capital M small m by 2r. This is the mechanical energy. So you can see very well, all these three terms are very similar. Now, how it is? See please, I have written U equal to, again I am writing, minus G mm by r. I have written kinetic energy is equal to G capital M small m by 2r, and I have written the mechanical energy how much? Minus G capital small m by 2r here. Okay, so when we will just if we see they are very similar now, so I will write here one relation, and this relation will come where? E equal to minus K equal to U by 2. Very important, even in 12th also, when you will study the Bohr model and all that, when the electron is revolving around the nucleus, that time also the same basics you have to use here. Okay, now if I talk about here the graph also, so let's take for example here, this side let's take R is there, and this side let's take energy is there, na? All kinds of energy. So you know kinetic energy is always positive. So if I will draw here the kinetic energy graph, the kinetic energy graph will be something like this, always positive. Okay, this is the kinetic energy. After that, if I talk about here the total energy graph, the total energy graph will be like this here, E. negative. And after that, if I talk about here the potential energy, so potential energy graph will be like this. Okay, so you have to remember this. Sometimes in the exam they may ask this graph also. Okay, students. Now next one, let's see binding energy of the satellite. Very common term because we have covered binding energy, escape speed, lot of things, is it? So see please, what is this? It is the negative of mechanical energy of the satellite. Okay, so first we'll write here the binding energy is given by minus of E, that means minus, and here minus G capital M small m by 2r, or we can tell here it will come how much here? This binding energy will come plus G capital M small m by 2r. Okay, but now what is the actual meaning of this binding energy? As I told you students very well, in the interstellar space, that means outside of the gravitational field of the planet, their minimum total energy how much? 0. And here what I am telling you, let's take for example backside also. Okay, we'll see now here. See please, this is the planet now, and here one satellite is there, it is revolving, and its total energy is what? The total energy is the negative. And let's take for example the satellites here. This is the satellite is there like this, and it's, let's take for example, total energy is minus 50 joule. Now, so to make this energy 0, how much we have to add? We have to add plus 50 joule. So that plus 50 joule will be what? That plus 50 joule will be binding energy here. Anyhow, we have to make the energy 0. Okay, so only this binding energy concept is coming. Okay, clear? And one more thing, students, if the reference of the potential energy is changing, then all these things will change. Okay, remember that reference matters a lot whenever we are dealing with the potential energy. Okay, great. Next one, students, very easy and used to come in exam. See please, work done in changing the orbit of satellite. Here now, as of now we know the satellite is revolving in some orbit radius r, but if in case the orbit is changing, then what will happen right here? Let's say again planet is there, radius is r and the mass is m. Now let's take, I have taken here one orbit, satellite is revolving in this orbit here, now this here, and here satellite is there, and this orbit radius is small r1. Now, so in this situation, if I will write here the mechanical energy of the satellite in orbit 1, this is orbit 1. So what we can write here, mechanical energy is given here minus G capital M small m by 2r1. Okay, now after that, if I change the orbit of the satellite here, changing the orbit of the satellite means here, let's take for example here this orbit is there, this orbit now, and now the satellite we have sent from which orbit? This orbit to the next orbit is there. Okay, and its radius how much here? r2. Okay, so what will happen when the orbit of the satellite is changing? That time we have to do some work, is it? So that only we are going to calculate, but first we'll write here the energy of the satellite in orbit 2, is it? So this one in orbit 1 E1, and now we are going to say in orbit 2. So what this will come here, students? See please, minus G capital M small m by 2r2. Okay, so whatever extra energy, because in orbit 1 satellite is having some energy, let's take for example minus 10. In orbit 2 satellite is having some energy, let's take minus 5. So minus 10 to minus 5, that means we have to use extra plus 5. That plus 5 is the work done, is it? So if I will write here the work done to send the satellite from orbit 1 to orbit 2 is given by what here? The change in the energy here, E2 minus E1 here, is it? So here what will happen that here, as I have told you, minus G capital M small m by 2r2. Now this is here again minus, then minus G capital M small m by 2r1. Now after that, if I will write here, this work done will be given by what here? G capital M small m by 2, and this one will come here, minus minus will become plus, that means it will come here 1 by r1 minus 1 by r2. This is the work done to change the orbit of satellite, because when the satellite will go away from the planet, its energy will increase like minus 10 to minus 5. So in this situation we have to do some work here, is it? Very easy concept, very direct question will come in exam, is it? Great. Next, students, we are going to see sometimes weightlessness condition also is important. So see please, weightlessness of an object inside a satellite of negligible mass here. So what I am telling that here, for example, if the mass of the satellite is ms, so this will be used to be approximately 0. Actually the moon is also satellite, but its mass is not 0. It is having some mass, actually heavy mass is there, is it? But now we are talking about the satellite, those who are having which mass? Negligible mass is there. So see please, let a particle of mass small m is placed inside a satellite which is revolving with a velocity v0. Okay, so let me draw here again. mass of the planet is m, radius is r, okay, and let's take for example, now we'll draw here the one satellite here like this. This satellite is there somewhat here now, and its mass is approximately negligible here. So now what will happen that here, let's take this satellite is revolving. This satellite is revolving in a orbit now, and orbit how much here? The orbital radius is small r, and the orbital velocity of the satellite how much here? V naught. Now what will happen that here, let's take inside this satellite there is the one object. Now I have put here one object is there, we placed here, and mass of the object inside the satellite how much here? Is small m. So you know very well here the orbital radius of this mass is small m also will be same. What will tell same? Small r only. Now can you guess how many forces will act on this mass small m? So first thing, let's here please here. First thing, weight of the object mg, and another what will be there? The normal reaction on the acting on the object, because object is placed on the surface of the satellite, okay. So mg towards the center now, and this normal reaction is there. So students, you know very well, as this point mass is revolving in a which path? Circular path. That means whenever anything is revolving in a circular path, what is there? Some centripetal force concept only is there, okay. So if I will write here, students, see please, from Newton's second law of motion, what we can tell? See please, from the Newton's second law of motion, net force. Now let net force, let's take here this Fg. Fg is how much here? Mg. So the net force how much here? Fg minus normal reaction. This is the net force. This net force will be equal to mass into acceleration. Now, mass into acceleration. Which acceleration? Centripetal acceleration. So let's put here please. This, students, if I write here now the normal reaction, so normal reaction will come here. Fg minus mac. Very easy going we are going. Okay. Now after that, what will happen that here? What is this Fg? Fg how much here? Let's take for example, students. Let's take for example here. This is mg minus m, and centripetal acceleration is given by what here? Centripetal acceleration. It is given by the v square by r. Okay, so we can write here v naught square by r. Is it? V naught square by r. Now students, let's move to the next one please here. No, this is mg minus. No, minus. Actually, we will not write here the mg. Why? Because we will write here in a general form. General form will write here, no? General form. No need to write the mg. We will write in a general form. So, you know very well what is the general form of the force formula from the Newton's law of gravitation. Yes, we will write here this one. G capital M small m by r. That is best. Okay. Now, after that, m and centripetal force is given by what formula? V square by r. That means V naught square by r. After that, see please, G capital M small m by r minus m by r. And what is the orbital radius speed? Remember, root g m by r whole square. Okay. After that, students, if I will just simplify this here, I will write here. No? I will write here. This normal reaction is given by what here? This one g mm by r. How much? G mm by r minus. You just simplify this. What will come here? G mm by r square. Can you get it here? What we have missed here? We have just missed this square here. This square. Okay. So what will happen in this situation? Both this term will cancel out, and here normal reaction will come how much? This normal reaction will come 0. That means if the mass of the satellite is the negligible, that means if any object we put inside that satellite, it will not experience any kind of weight. That means it will be in a which situation? It will be in a weightless situation. So only the normal reaction is coming how much? It is coming 0. Okay. So that only we have to see here. See, as normal reaction is 0, thus an object in a satellite will be in a state of weightlessness. Which kind of satellite? Weightless satellite. Now see here please, important points as I have told you. See please, condition of weightlessness can be experienced only when the mass of satellite is negligible, so that it does not produce its own gravity. Okay. Next one, see please, weightlessness in a satellite can be overcome by creating artificial gravity. And how we will create this artificial gravity? This artificial gravity will be created by rotating the satellite in addition to its revolution here. Okay, this thing is clear. Massless satellite we was talking about. But this thing here, see please, Moon is having mass, so it is having its own gravity. Now, Moon is having its mass, so only it is having its own gravity. For Moon, this concept is not applicable because the Moon is having the mass. Okay. After that, see, as I have told you in the starting of the video, geo-stationary satellite. Very important. See please, few points are there. See, it rotates in an equatorial orbit, and that is called which orbit? Parking orbit is there. Okay, so let's say here, for example, here mass of the planet is m, radius is r. So this orbit, equatorial orbit, where is the orbit here? Let's take like this here. This orbit I'm talking about here, this orbit in the equatorial plane. Here the satellite is revolving here. Okay, in the equatorial orbit. Next one, its angular velocity and time period is same as that of Earth. And please remember that here, the time period of this satellite will be how much? 24 hours. Please remember that very well. Use it in a question. Third one, please, its rotating sense is same as that of Earth. That means where to where? West to east. Is it? Fourth point, its height from the Earth's surface is how much here? 6 RE. This data we should all remember that here. And the fifth one, its orbital velocity is around how much here? This orbital velocity is around 3.1 kilometer per second, and that is which one? Geo-stationary satellite. And at the end, we are reaching to the polar satellite is there. And what is this? See please, it rotates in a polar orbit. Then how to draw the polar orbit, students? See please here. See here, mass m, radius r, and this will be my polar orbit here like this here. In geography and all you have studied na, here satellite will revolve here. So polar orbit is there. Second one, its time period is how much? Approximately 100 minutes. It heights from the Earth's surface is between 500 km to 800 km, and the last point, its orbital velocity is around 7.5 km per second.